Hi grade 9s, I'll be looking at the class test that you wrote on the 13th of March. For question 1, it asks us to simplify. So for 1.1, when I simplify this fraction, I can actually keep my base and subtract my exponents because that's what the laws of exponents say. 4 minus 3 is 1, therefore my answer is only 3. Then for question 1.2, it's a good idea to simplify your numerator first. Again, if I'm multiplying, I can keep my base and add my exponents. And 1 plus 2 is 3, and it's all over y to the 3. Then I'm dividing, so I can subtract my exponents. So I can keep my base of y and say 3 minus 3 is 0. And you know that anything to the power of 0, whether it's a number or a variable, is equal to 1. Then my answer is 1. Then when I look at question 1.3, I'm going to split up my numbers from my variables. When I simplify 16 over 24, I have 2 over 3. Then I can simplify my variables, and I'm going to split up my variables as well. So x to the power of 2 divided by x to the power of 3, I can keep my base of x, use my laws of exponents, and subtract those. So 2 minus 3 is negative 1. Then I'm going to look at my variable y. So I'm going to keep my base of y and say 4 minus 2, which is 2. And then the z is all alone, so I'm going to just keep it where it is. And it's a positive 1, so I don't have to even put the 1 there, but then that is my answer. Now, there is another way to simplify this question, so I will show you how to do that. So again, if I simplify 16 over 24, I do get 203. And then when I look at my x's, I can actually divide these out. So I can take 2 of my x's from my numerator and 2 of my x's from my denominator, and then I'll have 1 x left in my denominator. When I then look at my y's, I can do the same thing and say that I'm dividing out 2 of my y's from my denominator and 2 of those y's from my numerator. Therefore, I will have 2 y's left in my numerator. Then when you look at z, it's all alone, so I can't divide it out with anything else. So I'll leave it in my numerator, and then that is my answer. So these two might look completely different, but they actually do have the same value. So we don't need you to leave it in positive exponent form. So you're more than welcome to do this, or you can do this one. Then when I move on to question 1.4, when you look at this, you'll actually see that these terms are like terms. So you need to first, before you get the square root of anything, say 15 of something plus 1 more of the same something is 16 of that something. So it's x to the power of 4, y to the power of 2. And then you can simplify as per usual. You can say that the square root of 16 is 4. And then you can say the square root of x to the power of 4 is x to the power of 2. And the square root of y to the power of 2 is y, and that is then your answer. For question 2, it also asks us to simplify the expressions. So when you look at the first one, 2.1, you will see that it's a binomial times a binomial, and therefore we can actually use FOIL. So it's our firsts, our outers, our inners, then our lasts. So like this. So when I actually simplify this, I get x squared plus 7x minus 6x minus 42. And then I need to always find some of my like terms so I can simplify it even more. So I have x squared plus x minus 42. And then that is my answer. For question 2.2, I need to distribute the negative 4 into the bracket. So I'm going to keep the 7. I'm going to carry it over. Then negative 4 times 2x is negative 8x, and negative 4 times negative 3 is positive 12. Again, I'm going to find my like terms, which are the numbers. So for my answer, I have 19 minus 8x. Then for question 2.3, this exponent over here means that I have 2 of those brackets because I have 2 terms inside the bracket. Only if it's 1 term inside the bracket, I'm allowed to actually multiply or distribute the exponents with the exponents. But because it's more than 1 term, I need to know that it actually means that I have 2 of these brackets. So if that was a 3, I would have 3 of the brackets. So now again, it's a binomial times a binomial. And then when I actually simplify this a bit, I get x squared minus 4x plus 16. Then I'm going to find my like terms. So I have x squared minus 8x plus 16, and then that is my answer. For question 2.4, I need to distribute the 3 with everything inside that bracket. And before I distribute a negative, I need to know that I need to FOIL these two terms first, the binomial with the binomial. So I can say this is 3x minus 9, and I can keep my negative and create one big bracket for everything that I'm about to FOIL. So this is x squared, or 2x squared, plus 3x, plus 4x, plus 6. And then I can actually distribute my negative. So I'll have 3x minus 9 minus 2x squared minus 3x minus 4x minus 6. And then I can find my like terms again. So everything that have little x's I will put together, and everything with the x squares I will put together, and then my numbers I will also group. So then if I actually find my answer, I will have 2x squared, that's negative, minus 4x minus a 15. And then that would be my answer. For question 3, it asks us to solve for the unknown. So with this, I want all the variables to be on the one side of the equals to sign and all the numbers to be on the other side. So I'll have 2p on the one side and then 10 minus 4 on the other side. So 2p will then equal to 6, and then I'm going to divide by 2 on both sides, therefore p is then equal to 3. For the next one, 3.2, again, I would like all my variables to be on the one side of the equals to sign and all my numbers on the other side. So 5x minus 4x, and then on the other side where the numbers are, I have 2 plus 3. So then 5 is equal to x. I don't have to do anything more. That is then my answer. For question 3.3, this one I need to distribute a bit first. So I'm going to distribute my negative 2, and I'm going to distribute my negative on the other side. So I have negative 4 and negative 2x, and then 6 and negative 4x. Then again, I would like to have all my variables on the one side of the equals sign, all my numbers on the other side. So I'll have negative 2x plus 4x on the one side and 6 plus 4 on the other side. So I'm going to simplify a bit. So I have 2x equals to 10, and then I can divide by 2, and therefore x will be equal to 5. So then moving on to question 4, this will obviously be the level 4 question. So it's a good idea to read this properly and look at what you're working with. So it says that you have Jack, Nick, and Seth, and they're brothers. So it's a good idea to sometimes work with little pictures. There's Jack, there's Nick, and there is Seth. So Jack, Nick, and Seth. So it says that the product of their ages is 175. So the product, which means times, of their ages is actually 175. Then it says that Jack and Nick are actually twins. So whatever variable I use for Jack, I need to use for Nick, because these guys need to be exactly the same. Then it tells us that Seth is x. So already I know that Seth is x. Then there's a times sign there and there. And then it says that x and y are natural numbers. And it asks us to write down an equation. So if it says equation, we need to have an equals to sign somewhere in terms of x and y. So we need to use x and y. So I've been using x for Seth. So obviously Nick and Jack, they need to have the variable y. But both of them have to be the same because they are twins. So technically I have y times x, which is equal to 175. And I can actually simplify this a bit, saying it's y squared, not 2y, because when you times and you have the same base, you add the exponents. So it's y squared times x equals to 175. So this is then my equation that I will use. And it only asks us for the equation in this question. The next question asks us to then hence or otherwise determine their respective ages. So I know that I have y squared times x, that's equal to 175. Now, if I break up 175 in a different way, I will actually know that 175 is actually equals to 5 squared times 7. So 5 squared times 7 is actually equal to 175. So y is actually equal to 5 and x is actually equal to 7. So I can say y is equal to 5, x is equals to 7. We know that Seth is x, and we know that Jack and Nick are both y. And then that is my answer. So Seth is 7 years old, Jack and Nick are both 5 years old. And if you actually times 5 by 5 and then by 7, you get 175. So that was the whole test out of 30 marks.